What's up everybody, it's UziNets. Today's episode 4 of my series, and we're going over routing. Static and dynamic routing. Let's go. First things first, what is routing? Routing is just the process of selecting the best path for data to travel across networks. For every type of routing setup, you're going to have IP addresses, routers, and routing tables to look at. So you guys have seen IP addresses before, they're just the unique identifiers. The router is the actual device that forwards data to the next router and the next router throughout the network. The routing table is the data that the router reads. It's a literal table of data that you're able to access through a command line interface. If you wanted some visuals, here's what a data table looks like in a command line interface. Cool, so now we can talk about static and dynamic routing. The only thing you need to know is that static routing is where you configure the routes yourself, and in dynamic routing, you get the routes configured for you automatically. So because of the easiness of things automatically updating, naturally, most large-scale operations will use dynamic routing, and static routing will be more for like smaller businesses, smaller operations. With that being said, small and large, doesn't matter the operation, either one can also use a combination of both. So something we have in static and dynamic routing is default gateways. This is an important concept. You could kind of think of a default gateway as sort of like the door from your local area network, which leads to the rest of the internet. So for example, if this computer right here is your local area network, it's connected to a router which has a default gateway, and this cloud represents the internet. That's a default gateway, that's where it takes you. The default gateway takes you out of your local area network. Another thing you should know about is connected routes and local routes. These don't really fall under static or dynamic, they're more like automated. Connected routes are the routes that are automatically created on your router when you connect them to other devices. A local route is basically the router just sending out its IP address to the network for people to find it. Now as you can see from this key, it has a L for local, a C for connected. And you can see the L and the C connected and local routes down here. But look at all these other letters. S, static, R, RIP, you have mobile, you have B, BGP, you have O, OSPF. These are all different types of routing protocols. And now we have some dynamic routing protocols to go over. As you can see, they break off into more specific types. You have RIP, IGRP, OSPF, EIGRP, BGP. And these descriptions right here, for example, distance vector. Distance vector protocol is where routers basically only know the distance and they only use a metric like a hop count. For example, from network D to network A, that would be 2 hops, 1, 2. IGRP is specifically used for Cisco. RIP is super outdated. Path vector is similar to distance vector, but path vector is where they know the entire path. And distance vector, I think for RIP, for example, it only goes to 15 hops, which is why it's so outdated. And a link state dynamic routing protocol is where the router really advertises the state of its own links. This way it builds a complete map of the network and it calculates the best path for itself. And OSPF, Open Shortest Path First, is the most widely used dynamic routing protocol in all of networking enterprises. We're going to be going over this one specifically for the purpose of this video. For the rest of this video, I'm going to be in Cisco Packet Tracer. If you want, you can download it and follow along. I'm going to show you how to make a dynamic route and a static route using OSPF. Okay, you guys, now we're in Packet Tracer. First thing I did, I went to Network Devices, took a router, and I dragged 3 routers up here. Then I went to End Devices, clicked a PC, and I dragged a PC to both ends. Next thing I did was go to Connections, click a copper straight through, and I connected all these together. I used the lowest number fast Ethernet ports for all of them. Right now I'll label them for you. Okay, so I spaced the routers out and I labeled the Ethernets. Next thing I'll do is show you the IP structure, and I'll show you visually using these circles. Okay, so here I tried to label out the networks. Each network is going to start with 192.168, and they'll be differentiated by the last 2 octets. Blue will be 10.0, yellow will be 20.0, green 30.0, and purple 40.0. Before we can even set up routing, we have to address the IP situation. None of these end devices and none of these Ethernet ports are configured to IP addresses. I wrote the configuration that you can use. This will set up the router with an IP address, and then the router can be operational. So now let's click router 1. Go to CLI, scroll down, type in no. And if this is your first time using a CLI, just follow this order of commands I have right here. You start with enable, then configure terminal. You then type an interface followed by whatever interface you're trying to access. In this case, we want to access the gigabit Ethernet 000. So you type in gigabit Ethernet 000. And now you're in this router interface. Now we want to type this command, IP address. And since this is in 10.0 network, we'll just use 10.1, 192.168.10.1. And the default subnet mask for a Class C IP address is 255.255.2550. Click enter. Now type in no shutdown. And you can see these red arrows turn green instantly. But we're not done. We want to exit this interface, and we want to go into the next interface. And that is this interface, Gigabit Ethernet 001. Enter the interface. Same command, but now we'll do 20.1 because this is the .20.0 network. No shutdown. Interface is up, and that's it for this router. Now we'll go to router 2 and do the same workflow. Into the CLI, no. Conf T for configure terminal. Interface gigabit 000 for this one. We're going to use 168.20.2 because we're in the .20 network and we already used .1 for this interface. So this will get .2. Don't forget the subnet mask, no shutdown, and the reds turn green again. Exit to exit the interface. Go into this router's gigabit ethernet 0/0/1. Configure the interface but use .30.1 for this one because we're now in the .30 network, and no shutdown. That's it for this router. Now the last router, router 3. Type in no, enable, configure terminal, type in interface gigabit ethernet 0/0/0. On this interface, we'll use 30.2 because we just used 30.1 here, no shutdown, and these just turn green. Now go into gigabit ethernet 0/0/1. Since this connects to the .40.0 network, we're gonna go .40.1 and no shutdown. Boom, red turn green again. Now I'm gonna go into the PCs and make IP addresses. Click the PC, IP configuration. For this IP, we'll use .10.2 because we already used .10.1, subnet mask. Remember, the default gateway is essentially the door used to get out of your local area network. So for this PC, this is going to be the default gateway. And earlier we configured that to 10.1. Now this PC, IP 40.2 because we already gave this 40.1 subnet mask. And same thing as before. This is the default gateway for this PC's local area network. So it's going to be .40.1. Now that everything's configured with IPs, we can get into the static routing. Now we'll configure the static routes. And if you notice, I went and put labels for all the IPs we just configured just to make things easier. So now let's set up a static route. Go into the router, configure terminal, and now we're going to type in this command, IP route target network subnet mask next hop. The target network is the network you want to go to. For this router, the target networks are this network and this network. It's already connected to these two networks. .30.0 will be the IP address. That's the subnet mask. And now it wants the next hop. To get to our next hop, we start right here and we go here. So the next hop is this address, 168.20.2. And now what we can do is type in that same command and just replace the 3 with a 4 for the 40 network. That's the first router. Second router, configure terminal. For router 2, you want to get to the 10 network. And for router 2 going to the .10 network, we start here and the next hop is right here, 168.20.1. Now we can type that command again, just change that to a 4 for the 40 network. And to get to the 40 network, we're going to start here from router 2 and go here to our next hop at 30.2. The last router, same commands. From the 40 network, we want to go to the 10 and 20 subnet mask. And the next hop from here is going to be to 30.1. Enter that. We can type in the same address, just change the 20 to a 10 in the IP. Show IP route to double check. And we see 2 static routes. So now that static routes are configured, we should be able to ping from PC1 to PC2. Let's go into the PC, command prompt, ping 192.168.40.2. And we got a reply. That's a reply. Ping was successful. So that is how you configure static routes. And now we're going to go on to the OSPF routes. First, I'm going to go back into each router and delete the static routes we just made. To delete the static route, you go into the router config. You type in the same command you typed in to make the route, just with a no in front of it. So I deleted all the static routes just to show you. Each routing table, you don't see any S for static routes. So now let's configure OSPF on router 1. Configure terminal. So we're going to type in router OSPF 1, enter. Then we'll type in the network command. And for router 1, there's 2 networks, 10.0 and 20.0. We'll start with 10.0. And it wants a wildcard mask. Just to visually show you, that's a subnet mask. And this is a wildcard mask for that subnet. To get the wildcard mask, you take the number from the subnet mask and subtract it from 255. So in this case, you're subtracting 255 from 255, and you get 0 3 times. Then you subtract 0 from 255, and you get 255. If you had a subnet mask that looked like this, the IP would be 0.0.3 because 255 minus 252 is 3.255. So our wildcard mask will be 0.0.0.255. And for the area, we'll just put area 0. Area 0 is always the default area. And then we'll type it in one more time, but switch the 0.10 in the IP address to a 0.20. Now we go to the second router, configure the terminal, router OSPF 1. Now we'll go network. And for router 2, we're connected to the .20 and the .30. So those are the networks we'll advertise. .20.0, subnet mask, area 0. Now same command, and we'll add the .30 network. Now we go to router 3, same deal, we're going to advertise the 30 and the 40 network, router OSPF 1, IP address, subnet mask, area 0. And notice how it said from loading to full, that's a good sign. Now we'll do this one more time for the 40 network. Now if we go show IP route, we can see 2 O's for OSPF in our routing table. In router 2, we see the same thing, O and a O, 2 OSPF routes. And in router 1, same thing. So now OSPF is configured. Just to double check, we'll ping from PC2 to PC1, ping 192.168.10.2. Got a reply, and that's it. We configured OSPF. So in your endeavors, you're going to notice that OSPF is way better than using static routes. OSPF routes automatically adapt and change to new network changes. Static routes will fail in those situations. They're very scalable, excellent for large networks. Static routes are very poor for large networks. They're very low maintenance. If one of the links go down, OSPF can reroute traffic, whereas in static routing, that line would just be down until someone reconfigured it. So all in all, just remember to use OSPF for medium to large dynamic networks where you need reliability, scalability, and a fast network flow. And that's it for today's video, y'all. Thank you for following along. Keep playing with Packet Tracer, keep messing around. I'll see y'all in the next one.